Okay.
Okay, that's a good catch because I would have been bad if I forgot. All right. So the only thing we did is really go over the video to let us know what Benford's curve is.
Well, it looks like this. So we haven't got a very good match. Let's look at the view counts. Now, number 1 is definitely the most common digit at the start of the view counts, followed by number 2. That's as it should be. But it goes a bit wrong there at the end, doesn't it? Let's try the number of comments on each number file video. Again, number 4 seems to come up more than you would have expected. Number 1 is still the top, but I don't know, it's not quite Benford-esque, is it? So the number file statistics don't seem to quite be following the way we hoped. But maybe that's because it's not a big enough sample size. We've only done just over 100 number file videos. But for those of you who are familiar with my other channels, yes, I do have quite a few other channels. So those of you who are familiar with those other channels might be aware that I've made, well over 1,000 videos on YouTube now. That's a bigger sample size. So I sent the statistics for all those videos to Daniel, and he did the same thing. And let's find out what happened there. So these are the stats for all my channels. And let's go through them one by one. First of all, the durations. There we go. Not Benford-esque, is it? In fact, number 1's not even top. Number 3 is the most common first digit. Now, we've had a bit of a talk about this, and we've got a few theories as to why the durations aren't working. But rather than putting them here in the video, I thought it might be more fun for you to think about it, propose what you think's going on, and put them in comments under the video. There's also a blog where we've gone into it, and again, there'll be links under the video in the full description, so have a look at that. But enough about durations. Let's look at the view counts and the number of comments. Plotting the view counts on all my videos. The most common first digit is 1, followed by 2, followed by 3, 4, 5, 6, 7, 8, 9. And the curve, well, quite Benford-esque. Not bad, hey? And looking at the number of comments, again, remember this is the first digit in these numbers. Have a look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, a lovely Benford curve there. So it looks like even the YouTube viewing statistics and the number of comments are following a Benford curve. Now, as I said, more information, links.
All right, so the rest of it isn't anything more to sit back and say, but I think this is a better way of introducing that concept. And this concept is talked about in the homework several times. And I just kind of laugh because it's kind of spoken as if we really get it. I think the context in which the homework goes into is about like credit card charges and expenses, or like credit card number uses. And they use this for like security fraud. They still do this now in terms of like trying to find out whether expenses are inappropriate. If we're looking at your credit card history of how you spend money, it's Benford-esque. But around Christmas, when somebody steal your wallet and they go out there and buy something that's different, it's like, whoa. Something might be wrong. We might need to freeze this person's credit card and stuff. But I think this video just really helped us get into understanding Benford a little bit more in something that's kind of irrelevant. And then for the essence of statistics homework that we did, then we kind of go back to that same concept. We're looking at the YouTube video durations, which was just communicated to us, right? Just communicated to us. All right, so what's the first question that we have? This is very similar to question 1 from our homework, right? That you still even haven't done yet, possibly, right? YouTube video durations. The table below lists leading digits of 317 inter-arrival internet traffic times for a computer, along with the frequency to the leading, God damn. All right, it lists the leading digit. Now forget this, I need to fix this. We're not finished with this yet. So this YouTube video durations, this lists the leading digits of 317. We're going to assume these are YouTube videos. I'm going to say 3077 YouTube video durations. All right, along with the leading digits expected by Benford's law, right? So we have that. Now, we're asking the first thing, you want to identify the notation used for observed and expected values. Now, this right here is very similar to what we've done before. in class. I think we went over it before. The notation used for observed is O, and the notation used for our expected values, right, is E, right? So that's just talked about in class. This is kind of a fact. They just want to make sure that you know that you've read and it's in here. Now, what I'm going to do for you, Deja, is I'm going to create a PowerPoint, right, with kind of screenshots of these items. And when you're going over number one, it'll have a picture of this question, which you'll just read to the class, kind of like everybody else has been doing, right? And then I'll also probably have a screenshot from the part of the chapter that shows us the notation and shows where it's saying what the notation is from the chapter. So once you get up to that part, you'll see it. And your job will really just be not only to read the question, right, but to also let the people know, like, look, you guys should have read this already on this page. And the answer right from this page, taken from the textbook, O equals observed and E equals expected, right? I think you'll be very comfortable with that. And let me know if not. This is the time to sit back and get you up to speed, right? Identify the observed and expected values for the leading digit of 2, right? Now, here's the thing. We got to do, yeah, I'll leave this as it is, right? But I'm going to change this. When I just changed upstairs, up top, we made it so that there were 3,117 YouTube videos, right? So 3,117 YouTube videos is going to have a different number from what we're saying right here, 0.176. Just change this number. 559. Right? So that's it. And essentially what we're doing is, since this right here, we talked about this in class, since the number values are not expected to be all equal, because Benford curve is not equal, which of those two equations are we actually going to use? There's one. We can either use n divided by k, or we can use n times p. Which one are we going to use? You remember, Deja?
Is divided by k.
And no, n divided by k is when they're equal. That's when they're equal. Benford's law is not equal, because remember, the curve kind of looked like this. The curve for Benford's law kind of looked like that. Kind of a downward curve. So it won't be n divided by k. That's when they're all equal. That would be us taking 3,177 and dividing it by 9 categories. And then we just have an equal number for each of them, right? So which we would use this equation, n times p. So what we have to do is we have to sit back there and look at the proportion. This is our p right here. And we use this equation and we're going to multiply it by n, and n equals 3,117. So that's how we get that math. And it essentially, if we were to do it for all of these values right here, we would do the same thing for each of those values. We take 3,177, multiply it by 12.5. We take 3,177, multiply it by, or let's say 0.097. We would do that for each category, since each of them are different. But this problem, right here, it's just asking about the leading digit for leading digit number 2. And the leading digit number 2, the p, equals this value, which is the same thing as that value. That makes sense?
Yes.
All right. Leading digit, leading digit, leading digit. So again, where I'll have the slide up there, it'll be the problem. I'll have exactly where the textbook is having an example of going over that problem. And your task will just really be this kind of relay off to the students. Now, are you on your computer, or are you on, what are you on right now?
I have both. I'm on an iPad.
Both?
Yeah.
All right, okay. Okay, now you know what? What I might ask you to do is this. You could log into the computer. Are you in the Zoom on the computer, or you're in the Zoom on the iPad?
The Zoom on iPad.
You're in the Zoom on the iPad. Okay, so what we're gonna do is
wait, on Monday I got a share screen?
Yes, because I won't be there, right? So Monday, you should probably make sure that you're on your computer. Just,
Okay.
I'll send you the PowerPoint. And the reason why I'm going to ask right now is that what I'm about to do right now, all this drawing on the screen, right? When you're trying to like do a little math problem for someone, that is so much easier to do on a computer rather than being on the iPad. The iPad is so limited, not very functional. So definitely make sure that you're using a computer on Monday.
Okay.
Okay. So use your results from part B to find the contribution of the psi-chi statistic from the category in leading digit 2. So this is 2, leading digit 2, right? This is kind of what we did in class. Remember how we had in class? I had everybody break up and do their own little category. We're going to do the observed minus the expected, square it, divide it by the expected. Now the expected value, we're changing this a little bit. Let me get out of here.
Yeah, I updated it.
Yeah.
Well,
Don't worry.
Like, well, I just now realized I never squared the number. But now that we're changing this whole number here, it's a completely different number. That's my bad. I didn't realize that.
Why are you apologizing if I'm changing it in real time, right?
Because like I was really looking, and I'm just like, huh, you really didn't square that number. Like, so it's just like the number was going to change regardless. But I was like, ooh, I really didn't square it.
Okay. I hear what you're saying. So let's put 2 right here and let's square it. All right. And the value that we're having is yeah. You know, we got to change this too. All right, the value is 604. Now, you know what? This is not your fault, Essence. I need to tweak this in order for it to be your user friendly. These should not be percentages right here. These should actually be values. So
Okay.
that's not your fault. But Deja, we will have this set up for you the appropriate way. I am so sorry. This is like, yeah, you're seeing a sweat right now. Just because we picked 1130. At least I thought we picked 1130 as it. But we'll focus on 2, right? And even if I don't update it, what you'll have right appropriately is you'll have at least the second one right. So we're taking the observe, right, which is that the 17%, the value is 604. So the math is 604 minus our expected, which is N, which we get from the 3,117 times that percentage. That gives us a value of this, what we calculated. So just like we did in class, 604 minus that, square it, and then divide it by the expected, going to give us another value. Let me put this number up here for you so we got it right. Wait, hold on. Wow, I squared the number twice. That's stupid. 604. One, 5, 2. All right. And then that math, 2011.34 divided by 559.152 is a value of 3.59. It might as well be 3.60. All right, so this math will be correct, what's right here. Now, do you see how to do this math with these numbers? I know the chart's a little misleading, but you follow us along what we're trying to do or trying to communicate to you?
Yes, I'm following.
Okay, perfect. All right, let me shrink this a little bit to let me know I need to come back in here and fix it. All right, so yeah, I'll fix those numbers and make sure it's right. Okay, so let me clear this just so everything is gone from that. So that's all you got to do for number one. It's a lot of time going through, but I think a lot of time is really because I've got to fix it like in real time. I didn't get to this yet. All right, so YouTube video durations. When using the data, identify the null and the alternative hypothesis, right? Now,
Now I want to say that I have since updated this as well on my
no
screen.
problem, no problem.
The
But you know what
values
though?
are there in my other one.
Yeah. Essentially what we'll do is this. This is actually to a certain extent true, right? The only thing is that we got to understand that the value of piece of one, piece of two, piece of three actually have values, right? So actually, let me ask you this. If you updated it, Essence, do you think you could copy and paste it and put it in the chat? You put it
Yeah,
in
I was really just thinking that.
Yeah, I'll put it right here in this document so we can look at the real thing as opposed to what we're supposed to do.
Okay, I can do that. 1 second. Now I don't know if the subscript is gonna.
Yeah, don't worry about that. We'll definitely get it.
Okay.
Yep, perfect. All right, so let's make this look kind of fancy. Right, so it's saying that piece of one equals this, right? And I'm going to change. Yeah, you know what? You actually are doing it right because it's not. Let me do this. I'm just going to change this so it doesn't confuse me or other students. Let's replace the plus sign with A and D. Because here's the issue. When you have the plus sign right there, right? That might imply to somebody that it's math. Like we're adding something, right? Replace.
Yeah, I did see in the textbook it had and, but you know.
Yeah. Let me see. Right, so that's what our hypothesis will look like. It's long, it's very long, right? Especially when you're doing it with text like this. I think if we kind of shrink it down, it might look a little bit. But we're saying with the null hypothesis, right, that we expect that piece of one is going to match the 30.1% predicted by Benford's law. The second category is going to equal the 17.6% of Benford's law. The third category, so on, so on, so on, so on, and so on, right? And that's why I think a better understanding of what the hell Benford's law is important, right? I'll have this up here for you on the homework in the PowerPoint, and you just want to sit back and kind of let the students know like why it's those values. Why are we picking those? And that's because it's consistent with that kind of graph. It's really just, yeah, just virtually looking at it. I think number two should be very easy. You let me know if you're lost or confused, though. I can definitely go over it to expand and make sure you're clear.
Clear.
All right, okay. And then next we have YouTube video durations. The accompanying stat disk shown in the margin are obtained from the data. What will be concluded when testing this? Well, actually, we won't do three. Yeah, I don't have it right here for you. I need to create like a stat disk thing that looks like the numbers. We're going to skip three. That's just going to be ridiculous. So let's go with four.
So,
we're on
so 1, 2, 4, 4, and 15. No, you
Yes.
said no 5 in the beginning.
Yeah, 4 and 15.
Okay.
You're right. Let me cross these out. Right. So 1, 2, 4, and 15. Yeah, not 5. Right. So next, YouTube video durations. Now this is kind of interesting, right? This takes a little bit of understanding. Remember how we were saying before that Benford's law, that's the way that numbers exist in reality, right? If numbers are random, right, they should be consistent with Benford's law. Now, if they're not random, which means like something's happening, like there's some kind of force out there, there's some type of truth that we don't know about, then they won't make Benford's law, right? So look at this right here. What do the results from the preceding exercise suggest about the possibility that the length of YouTube videos are intentional, right? Intentional means they're not random, right? Is there any corrective action that could be taken? Honestly, I would say forget about this item right here, the corrective action. But since the data that we got, and again, we'll see that with the chi-square that we're doing, these numbers that we gave do not match. I mean, 19, yeah, 19, these are going up a little bit higher. The 16 and 10, 11, they're not matching Benford's law perfectly, right? So since they're not matching Benford's law perfectly, then that means that they're intentional. So to answer the question, what do the results from the preceding exercises suggest about the length of the YouTube videos being intentional? The answer is this. The length of the YouTube videos seem to be intentional because they do not fit Benford's law. If the length were random, they would apply to Benford's law, right? But since they're not applying to Benford's law, that means that they're not random. Now, you could kind of talk about this next issue about a corrective action, but here's the issue. When you think about YouTube videos, this is something that people probably don't know of, but I know a little bit. I know some people who do YouTube videos. You can monetize them. I think in this video, we actually had like a commercial at the very beginning, right? You make more money the longer your videos are. If your videos are 10 minutes long, you make a certain amount of money. If your videos are 30 minutes long, you make a certain amount of money. And if they're an hour and you're getting like $5 per view, literally, from watching these things. They watch the entire video. So to answer that question, I really do think that they are making these videos intentionally 30 minutes. Because one, if they're 30 minutes, you make more money per view. It's almost like an episode of television. The money that people get paid for these commercials are driving this aspect. So I think that's the reason why you look at Benford's, if you go back up to the data they were saying, the leading answer when they were doing all his data, actually this data doesn't say that, but in his videos they were looking at, the number one answer was the first digit was 3, which to me is saying that those videos are about 30 minutes long. And that's exactly where you get more money. Trust me, if I'm making money off the internet, that's what I'm gonna do. But you don't have to go into what I just said right now about knowing the aspect, but just the fact that since they're not following Benford's law, then they must be intentional. Because if they were following Benford's law, that means they just make these YouTube videos and it don't matter. It could be 5 minutes, 10 minutes, 15 minutes, 30 minutes. It could be anything. But since it doesn't follow Benford's law, yes, something's going on. They definitely are intentional because they don't fit that random prediction of what Benford's law is all about. All right, let me see. Now, this right here is the mega problem, I would probably sit back and say, right? This is what's really going to be following through everything that we did. I'll probably help with the PowerPoint. It'll be a PowerPoint that has like this image right here on it, and you have to kind of walk through it, right? But we're going to walk through it right now, and then the PowerPoint aid will be there for you. Let's read this problem. Actually, you know what? Instead of me talking, can you read the problem off for us, Deja?
Sure. The table above lists the numbers of different candies in a variety assortment bag purchased for Halloween. Dr. Brown argues that the manufacturer uses Halloween to dump candies that no one likes. So there will be more Milky Way and 3 Musketeers in this variety bag. The proportions are listed on the table. Use 0.05 significant level to test the claim that the actual numbers of the different candies fit the distribution indicated by the expected proportions.
Okay. All right. So we got to go through everything with this, right? Now, the first thing that we got to do is figure out what our claim is, right? To help us do our null hypothesis. right? What would be our null hypothesis? You know what? I might pick on Essence for this since she just worked on that. But our null hypothesis is going to be two things. One, I'm not going to ask on Essence just yet. I will ask you, Deja, just to see if you can work on it, and then me and Essence will help you if you don't have it right. What do you think the null hypothesis would be? And I'm going to think back about how we did the one before with Benford's Law. Benford's Law had 9 of them, right? And they were listed. But this right now is a little bit easier. It only has 4. How do you think we're going to write this null hypothesis? Are you okay?
Yeah, I'm just looking at the problem.
Okay.
Would it be 21?
No, it wouldn't be 21. I'll sit back and help you then. What we got to do is we got to look at the probabilities, right? So we're talking about what will the probabilities be of each. So the focus should be on the probabilities. And I'm going to highlight all those probabilities right here. Right? So this is the probability that'll be in there. This is the probability, this right here, and then that right there. Right? So we got 4 categories, not the 9 that we had before. Let me get over here so I can click on this again. All right, I'll start it off and then hopefully you can take it from, right? So piece of 1, I'm gonna say that's like the Snickers, right? Piece of 1 equals 0.17. And then we kind of went over this correcting from how Essence brought it in. And then it's also going to say N. So what would be piece of 2? Piece of 2 would be what?
It's 33.
All right, 0.33. And what next?
It'll be 0.33.
All right, 0.33. And piece of 4 will equal
0.16.
0.16. All right, excellent. You got it. Right. And it's really just looking at those probabilities. That's what we're predicting. We're predicting because, again, Dr. Barnes argues that we're trying to dump these candies that nobody likes. I hope nobody likes Milky Way or Three Musketeers. They nasty to me. Right. But we're dumping them. Right. So then our our alternative hypothesis would be that 1 or more will not be as expected. You could put it in a fancy language, but essentially we can disprove the null hypothesis if 1 or more of these are not as we predict. That's all it takes. Now, it's not just exactly, but it has to be statistically significantly different, right? And that's what, and again, I'll sit back and have the little aspect of the textbook that's showing you where it is, to show you how it's consistent, to make sure that the people in class can be like, oh yeah, if I read, I'm not sure people are reading, but if I read, right, it should have, I probably came across that, right? So that's the first step. First step is to do the, the hypothesis. Say step hypothesis, that's step 1. That's the very first step, do the hypothesis, right? Now, I'm gonna clear this, right? We got it on recording. The next thing we gotta do, step 2, is to get the expected values. So let's do the expected values. All right, now we got 2 equations, remember? It's N divided by K. We just did this in class. If we think that all these categories are equally likely, or it's N times P if we think these categories are going to have different likeliness, right? So which one of these equations will we use?
Wouldn't it be N divided by K?
No, you know what? I'll make sure I have this on the screen again. Let me do this again. See if it's on the screen.
No, you just said it's because it's not equal to, so it will be N times P.
Exactly, right? And it's consistent with this right here. This is kind of like the fact. I'll make sure I have this on the slide to remind you, right? But as long as people are going based off of this fact, you always got to go back to the source information. Yeah, it's saying that they're not equal right here. So it's NP.
So if they were showing, like if the probabilities were all like 0.25, then that's when you would want to go with the NK because the probabilities were showing they were equal.
Exactly, exactly. And again, I'll have this picture on the slide in PowerPoint. So Deja, I'm not needing you to remember it like, you know, you got up in the top of your head. It'll be on the slide when you're going over that part of the problem. So that all you got to do is kind of look at it and be like, all right, now since we're saying that they're not equal, because Dr. Barnes said they're giving away more Milky Way and more this, right? We're going to use N times P.
Okay.
All right. So the next step would be to find out what the expected values are. We got to calculate them. What do we think the expected values would be? And I'll let you, if you got a calculator, to sit back and do all of these. First thing we got to figure out is N. N's going to equal, adding all those values up, 21 plus 34 plus 40 plus 25. There's 120 candies in the bag, right? So what will be our expected frequency, right, for Snickers?
It's 120.
No, remember, 120 is what's totally in the bag. Now, what's in the bag, we got Snickers candy, Milky Way candy, Three Musketeers, and then Reese's, right? Now, we're predicting that 0.17 probability is going to be Snickers, right? So if there's 120 in the bag, what number would we expect to be in there if 0.17 probability are Snickers? That goes back to right here, N times P. That would be 120, which is the N, and the P is 0.17. That's the P. N times P is going to equal our expected value, and that equals what?
2040.
All right, and I think you must have forgot the 0.17. I think you did 120 times 17.
20.4.
20.4. 20.4, right? So I'll write here the expected value is 20.4. This will be in the PowerPoint for you when you go to the next slide, but it's good to have the students kind of go through what you're doing, but you'll have the answers, all right? Now, again, since you're struggling with this a little bit, practice makes perfect, right? What would be the expected value for Milky Way?
$39.6.
All right. 39.6. Now, since these are the same, it's going to be the same, 39.6. And then what will be the last one for Reese's?
19.2.
19.2. All right, so we got all these values. Excellent. I'm going to make sure I have these numbers over here in the corner for us so we can remember them. 20.4, 39.6, 39.6, and then 19.2. Right, so those numbers will always be there as long as I erase them the right way. All right, so that's the next step. Step number 2 is to figure out the expected values. We did that. Okay, now, step 3. And I have different slides in the PowerPoint that's saying step 1, step 2, and step 3, setting you up. So all you got to do is kind of make sure you understand what we're doing right here. And then just kind of fill in. I'll let you know what step 3 is. I'm not even putting the pressure on you to remember, okay, step 1 equals, no. It'll say step 1, figure out the hypothesis, and then the information will be there to help you. Step 2, figure out the expected, and then the information will be on the slide to help you. Step 3 is for us to calculate the that equation, which is, let me show you what it looks like. It's the summation of O minus E squared divided by E. Now, luckily, it's only 4 items, right? But this is kind of what we did in class. So just to make sure you're comfortable with it, because again, you'll have a little bit of pressure on you because you'll be doing this in front of the students. Can you read off, what will this equation look like? What will it be? And if you need help, just ask for it. I'm not trying to put you on blast right now. This is to learn and get better.
All right, so it would be the expected, right?
All right. Yep.
20, what? 20.4.
All right, now hold on. Remember this. 0, I mean, this O right here is for observed. And then the E right here is for the expected. So you just gave me the numbers in the different direction. Observed comes first.
Sorry, 21 minus 20.4 squared over 20.4, I think.
No, you say you think, but you got it right. Again, that's why I was saying practice will make it so that all this will come a little bit perfect. So what's the next one would be?
34 minus 39.6 squared over 39.6.
Over 39.6. All right.
40 minus 39.6 squared over 39.6.
Excellent.
$25 minus 19.2 squared over 19.2.
Excellent. Now, we can go through and do these problems, but what I'll do is this. I'll promise that I will give you these values. Once I think it's important for the students to help you do this, right? Ask for some volunteers to work through this. So you need to be comfortable with making sure that you put observed first, minus expected, right? And don't tell them to solve the problem, right? But just have them, have you help them read them out, kind of like what I was doing for you, right? Now, and then later have them sit back and calculate each of them, tell them to do one, calculate them, see if they get the answers right. But I will have the answers for you, right? So once you give them, once they all give them to you, once you move to the next slide, the answers will be there. And it will be an opportunity for you to double check them, right? The opportunity will be there to double check them. So yeah, we don't have to do that right now. I don't want to sit back and use unnecessary time spending on them. Actually, you know what? For the video, maybe it is important for us to do that. And let's just do them real quick. And actually, you know what? With Ethans, you still being here, if you start from this one right here, I'll do the first 2. Deja, if you're comfortable, you can do the last one. And we'll make sure we have them just so that you can watch this video over and come back to it, and it will be in real time for you.
Okay, so I'm doing the math for the third one.
Yes. All right, let's go with Essence first. Are you done?
Yeah. So
What do you get?
rounding to 3. So it's 0.00404.
0.00.
404.
All right, so I'm just gonna say 4. It's running to 3,
Oh, okay.
right? And then what'd you get, Deja, for the last one?
I think that's off though. But I got 1.75.
Now, you know what? The only thing wrong with you, Deja, is your confidence. That's exactly what it is. That's what I got on my calculator. I was just sitting over here waiting to see if you messed up or you got it right. That's exactly what it is. What made you think that something was wrong with it?
Because at first I almost didn't I forgot I had to divide.
Yeah, you're absolutely right. Absolutely right. Now, to show you the math, just so it's in this video, in case you want to watch this video again to help you get prepared with the numbers. When you sum all these values together, the number we get is 566. That's our chi-square, right? So when we do this, our value of chi-square is 2.566. Now, we didn't do this in class, but I'm going to do it right here just to make sure that I will do it. Now I have a table and everything ready for you. Let me go and log into the textbook. Vital source. Bookshelf. At a table that we'll look at, and I'll have this in the PowerPoint too. So all you got to do is maybe go to the next slide and it'll be there for you. We're going to go to table A4. I'm about to share screen in a second, so you'll see it. I know you guys can't see what I'm looking at. Oh, here it is. Oh, I'm so done. These people calling me. Don't y'all got jobs? All right, so let's resume share. Okay, so when it comes down to, this is the table that we'll look at, right? We need to find out what the critical value is. And I kind of alluded to this real quickly at the end of class, right? Just because I want to go through it, but we got to find out what the degrees of freedom are, right? And the degrees of freedom are going to be K minus 1, right? K is the number of categories, right? And do you remember how many categories we had?
4.
Yep, 4, right? For each of the candies, Milky Way, Musketeer, Snickers, and Reese Cups, right? So degrees, categories is 4. Degrees of freedom will be 4 minus 1. So we'll be up here. Let me highlight this so we can see where we should be. We'll be right here for 3 degrees of freedom, right? Now, they also said earlier in the problem that our significance level is 0.05. So essentially, we got to look at this graph and find out where these things meet up. They meet up right there. Right? So that's our critical value. In order for us to say that there's a significant difference, in order for us to say that, man, that's that null hypothesis that you wrote, right? About the value, Dr. Barnes thinks that they equal this value. In order for them to be different, we have to believe that we have to have a critical value different from that or greater than that. My kids are funny. All right. So The value that we got is 2.566, right? Now, I think I'll make this for you. I definitely will. I'll sit back and have a number line, right? It's a straight line. That's like the straightest I ever done a line, right? And I'll have a mark right here for the critical value. And I'll list that as 7.815. So there'll be a PowerPoint slide that will have a line like this, and it will have the critical value being 7.815, right? And 0. What you'll have to do, right, is remind them, look, guys, we just calculated a value of 2.566, right? If 2.566 was in this critical region or higher, we would reject the null hypothesis, right? But since it isn't, since our value is actually, I don't know, let's just imagine it's right here. Somewhere along the lines right here, you don't have to be specific, but 2.566, it's not in that extreme region. It's not greater than that value. So we cannot reject the null hypothesis. So what Dr. Barnes suggested, thinking that these candy companies actually be dumping these nasty candies in their bags, that is exactly what we found. It really is exactly what we found in this result, because we can't disprove that hypothesis. Now, if it were greater than, then we'd be like, no, Dr. Barnes, you bugging, right? It's not how you predict it to be. But since it's not in that critical region, yeah, we have to agree. Dr. Barnes is right. Yeah, Dr. Barnes is right. We should do that. That should be our lab if y'all can get this stuff right for that aspect. But I have a PowerPoint slide for that as well. I'm going to work on the PowerPoint slide right now, Deja, just so I can send it to you. This video will also be sent to you that you can watch. I encourage you to do this if you're going to watch the video over, because again, I think you heard me, but I'm going to change things up just a little bit. I wanted to make it so that if everybody was dedicated and did a good job on what we're doing, as long as you're trying to teach this course, you get 100% on the 11.1 homework, right? But I am looking for making sure that you're a little bit more competent and you're able to present. Because again, I think it's a slippery slope, and we had people do the one the last one. I just was kind of upset. It was almost just like, yeah, I don't care, whatever. And it wasn't really responsive to people learning or making sure. I don't even think they understood it. So I will grade you on this, although I think the grading is going to be 100% if you're doing your best and I see that you understand it. If there's like 1 or 2 mistakes, I might go down to like a 90 or an 80. I think an 80% might be the lowest I'll give people. But again, if you put your best foot forward, you can get 100% as opposed to an 80%. So yeah, I would suggest you to watch this video. And the thing I'll say is this: when you make it a YouTube video and I put it up there, you don't have to watch it at speed. We're doing this right now in real time, right? But if you go to a YouTube video and you look at the little, like, I think it's a little, looks like a gear, you click on that, you can speed it up to be like 1.25 speed or 1.5 speed, right? So you can listen to this while you're doing the thing that you got to do. You probably don't even have to look at it, right? Unless it gets to a point where you're a little confused or you want a reminder. But definitely make sure that you go back to this. We can kind of help you. It's a great preparation to what we're doing. And then I'll also send you the PowerPoint. And the PowerPoint will, when you look at that, it'd be a nice way to have you kind of walk through all the stuff you see and to make sure that I have stuff prepared. And let me know if the PowerPoint, if there's something that you think would be added or better, just let me know. And I can add something. I can add a note. I can add something to help you do a better job on Monday. Now, are you really following me? You good? Is there any questions you lost or anything?
No, I really was following you. I was writing stuff down.
And that's perfect. That's exactly
I was
exactly
writing
what we're
notes,
looking
taking
for.
notes.
Yep, that's exactly what we're looking for. Again, I don't know, write my number down if you don't have it, but I'll put it in the chat. I'll put this in the chat. I'm going to put my phone number in the chat. In the event that you have any questions going over anything and you're nervous or you can't make it to class or you want to go over a part of the video or you just don't get it, right? You can text me anytime, right? Now, here's the issue. If I'm busy, because it's Friday, or I had a little bit of fun, right? I just won't respond
He will
back.
not answer your phone. He will not.
See,
He will
Essence
leave
no,
you
Essence
on
no.
red.
But hold on.
You gonna be really you really gonna need help with something. This man will not answer you, and then just send it back to you later.
Exactly. I'll get it back to you later, but I do get back to you. I do get back to you. So don't sit up there being like, oh, I need some help at this very, very moment. But yeah, don't hesitate. If I'm busy, if I'm with my family, if we're eating, if we're doing something, driving, I'm just gonna get back to you when I'm comfortable and safe to do so. But don't hesitate. I don't want you to be like, you know what, I'm confused, but I don't want to bother him. Trust me, the phone, you saw how the phone went off right here. And it's like, what the hell? That's the worst that could happen. I'd be like, what's going on? But let me tell you, if I looked over and I found out it was a text from you when I'm done this, I'm gonna get right back to whoever called me or text me when it's over. So, and you'll never know that. But yeah, so don't worry. I'm here to help. I want to make sure that you're good. That's why we're recording this. I'm going to make a PowerPoint to support you. I appreciate your patience because, like I said, there's a little bit of tweaking I was doing in real time in front of you. I hope it didn't confuse you, but I'm going to make a PowerPoint that's a little bit cleaner. And so it'll be easier than what we went through here. So if you can follow this, which was a little cluttered and us trying to make the most out of it, you'll be real good when it comes down to in class because your presentation of your tool will be a lot easier.
Okay.
All right. And the only thing I would say is this, since we didn't do it here, since you're not on your computer, you might want to jump into your own Zoom, right? Jump into your own Zoom by yourself, right? Or you can jump into my personal meeting room at any time over the weekend. Any email I send out has my personal meeting room. My personal meeting room is set up so that anybody can jump in at any time, I believe, and you can do this, the annotation, you can start doing the screen. So the one thing I'll tell you is this, I'm getting real good at it, right? You saw how I did that little straight line over here, right? I do that line. I'm getting good at it because I've been doing it for a while, but it is worth jumping into this and playing around and trying to write, you know, maybe numbers 2 plus 3. I think Narice one time, she was in here and she was like writing the number 4, it looked like that. And she's like, oh my God, I can't do it. But then just writing just the numbers 0 through 9, she did it 4 times. It was almost like a child doing handwriting. By the time she did it a 4th time, it just got neater and tighter. So if you're a little worried about how you look and if anybody might giggle or your numbers looking off, you might want to jump into the Zoom, do share screen on the PowerPoint that I give you, and just try to write the numbers 0 through 9, 3 or 4 times. And I promise you, you'll get the control. You know how you got to move your finger a little bit. And then when it comes to time on Monday, they won't see you sweat. They'll just see how good you are after practicing what? 9 digits, that's practicing 36 digits. I really believe at the 36 digits, you're not gonna get any more better than that. So that'd be a suggestion. Jump into my Zoom anytime. Actually, depending on how free I am, just to prove Essence wrong, I might see you jump in my Zoom and I'll be like, hey, what you need? But if I see you in my Zoom this weekend, I'm assuming that you might do this. If you want me to jump into Zoom and join you, don't jump into Zoom sporadically. Send me a text and I'll let you know like what time I can meet with you. And yeah, we can jump into Zoom and make sure we're good.
Okay, great.
All right, that was just an hour. Just an hour. So I'm gonna stop recording now. Thank you so much. I'm wishing you good luck on